do this in one recording because I wanted to get it all in one thing. If it gets too long, I'll split it up into two though. I'm using this final exam review from Colgan because I basically modeled your final exam after this. It's it's all multiple choice and it should probably take you an hour or less. It's really not that difficult. So I wanted to kind of take you through and show you how I went through all these problems. Make sure that you guys are um, taking the time to know this material as best you can. And hopefully it might help you with your SOL that you have tomorrow, hopefully. So let's see. Move this real quick. There we go. I'm going to do this in line. Right here. Okay. And here we go. Okay, so remember that I taught you guys how to slide and divide with this. So what you're going to do is multiply this 5 times negative 28. Okay, so I multiply 5 times negative 128, and I get negative 140 right here. And I want to find out what two numbers add up to 13 but multiply to negative 140, because what we're going to do is turn this into now, I'm going to make sure this line is smaller. We want to change this now into x squared plus 13x minus 140. Okay, so that is negative. Let's see, we'll take a look at it. It's 14 times 10. Okay. Oh, that would be 20 and negative 7. Okay, so then this ends up being x plus 20 times x minus 7. But I'm not done. I have to bring back this 5. So I divide everything by 5. And as you can see, 20 divided by 5 divides evenly. So this now turns into x plus 4, right? And then this, because this does not divide evenly, I bring up the 5 to the front, and that becomes 5x minus 7. Okay? All right. Now, when we're doing 125, when we're simplifying this, remember, when we're doing square roots, we're looking for sets of 2. So the first thing I want to do is group together, factor out 125. I do that by doing prime factorization. So that's 5. And then 125 divided by 5 is 25. So that's 5 times 25, which is 5 times 5. Okay, so, and then this is what happens here. I get this, I turn this into a radical. And so this is equal to 5 times 5 times 5. And x to the 4th is equal to 1, 2, 3, and 4. And then y to the 5th is 1, 2, 3, 4, 5. And if you kind of notice, I grouped them all in 2. So what happens is I take out my sets of 2. So this guy comes out, he goes in one car. This guy comes out. And everything that comes out, it comes out as only 1. And they get multiplied together. Okay, so these y's and these y's, right? So on the outside, I have a 5, and then I have 2 x's, so that's x squared. And then I have 2 y's, which is y squared. And then what's left in the house? That would be 5y. Okay? So that's how that is simplified. Okay, so when we're doing f of -3 for this function, there's several things that you could do. I'm going to go ahead and just plug it in. Now this is, I would also recommend that you use Desmos for this. In fact, I'll try to use this for, well, no, I'll just plug it in. So you can use Desmos for this. So f of -3 is what is the output when I plug in -3 for x. So I need to be careful because this negative is still there, and I add a -3, and I square it, and I do -9 times -3. Okay, so -3 squared is a +9, so I have negative and 9, and this becomes plus 27, right? So then that becomes a positive 18. Okay? Now here, what we need to pay attention to is when you're solving an equation with variables on both sides, is you want to distribute first and then bring the variable over to one side as quickly as possible. So the first thing I'm going to do is I have 7k plus 22 is equal to 7k plus 14 minus 6k. Now, I have like terms on one side of the equal sign, so I'm going to combine these first. I do not bring them over one by one. That leads to a lot of error, so I just want to be very careful with that. So I end up getting 7k plus 22 is equal to 1k plus 14. So I bring the k over to the left side. So I take that when I'm moving on to opposite sides of the equal sign, that's when I use my inverse operations. So I have 6k plus 22 is equal to 14. And then I subtract 22. So I get 14 minus 22. That's equal to -8. So I get 6k. Oops. 6k is equal to -8, and I divide both sides by 6. And so I divide by 6. And that ends up being -4/3. Please do not get afraid of having a fraction as an answer. And if you ever have a question, you can plug this into your equation to make sure it works. And guys, there should be no question about, you'll have plenty of time to do that, so please take the time to do that. Now, when we're solving an inequality, we want to bring the variable, I like to bring the variable to the left side, okay? So I'm going to subtract 2x from each side. And I get -1x minus 9 is less than 21, okay? Then I add 9 to both sides. Now I have -1x is less than 30, okay? Now I need to divide by a -1. So when I divide by a negative number, that means I flip my sign. So it's going to be x is now greater than -30. So be very careful of that. Now, to determine the slope of the line passing, remember your slope equation is y2 minus y1 divided by x2 minus x1. Okay, and I can label my points x1, y1, x2, y2. So my slope is 7 minus -4 divided by -3 minus 6. So this ends up being 7 plus 4, so that's 11 over -9, and then it's just standard form to bring it to -11 over 9. Okay? All right, so given the relation of this, which replacement for a makes this relation a function? So when it's a function, our x values do not repeat. Okay, so first things first, I see a 2 in this x value, so that's one that's not going to work. Then I have a 0, that's not going to work, and then I have a 3. So the only one that would work is D right here. Okay, now I also showed you guys how to do something like this. It's the ugly math. Remember, I showed you how to do the ugly butterfly problem, where you're going to divide 4 divided by 4, and that's 1, and then you do 2n squared divided by n, so that's plus 2n, and there you go, right there. You could also factor it out, but this is a pain to factor out, so I would suggest doing something like this. It's a very common SOL problem as well, so be prepared for that. Okay, so when we graph a system of inequalities, now I want to make sure you guys can use Desmos for this. I want to show you what that looks like. So let me pull up Desmos for you. Okay, so big thing for that is, let's see what our problem is again. Sorry. We've got y is less than or equal to negative 3x minus 1. So I'm going to, y is less than or equal to 3x minus 1. Now, one of the nice things about Desmos is you don't have to put things in slope-intercept form in order to graph them. So I could just do this. 4x minus 5y is greater than 20. So 4x minus 5y is greater than 20. Okay, so I'm going to zoom out. And my solution is where both the red and the blue overlap. So this is your solution right here. So I'm going to go ahead and just make a quick screenshot of this. Okay. And hopefully it'll paste on. Oh, no. Okay, never mind. But that gives you an idea of where that is. So remember to go back to here. You can do that. All right. So hopefully you can see that. All right. So now I'm going to move on to the next one. Okay. Direct variation. One of the things I want you guys to understand is direct variation. Any equation that's direct variation is, first of all, do this again. Sorry. Direct variation. So direct variation is in the form is equal to the form y is equal to k times x, where k is really just essentially the slope of the line. It's always a line that directly goes through the origin. So here's your coordinate plane. And as long as it's a line that goes directly through the origin, it looks like that. And then for each one, you want to do y is, you're going to calculate k. So k is equal to y divided by x. And for each one of those, that's going to be a, for each one of these are going to be the same. So first of all, this is not direct variation because it's not a line. This one is, because this is the same thing as y is equal to 1/2 of x, all right? This, however, is indirect variation, so that is not one. And if you ever have any question, go ahead and graph this. So if I did f of x is equal to x over 16, well, if I go into Desmos and I look right here and I go y is equal to x divided by 16, as you can see, that's a line that goes directly through the origin, so that is direct variation. So this is direct variation. So this is direct variation. And then for here, I'm going to calculate y over x for each one of these. So 12 divided by 3 is 4, and 6 divided by 6 is 1. So already, when y over x is not the same for all the points, that is not direct variation. Okay? Now, when you write an algebraic expression for a verbal expression, remember that when you have less than, that usually does not mean this, okay? Is less than or is greater than is usually these inequality signs, okay? Less than means subtraction, but it means you change the order. Okay, so first let's look at the quotient of x and 9. Now quotient means that we're dividing, and then I said 7 less than that quotient. So it's x divided by 9 minus 7. Okay, and then the next one is right here. We have this one right here. So here I'm going to simplify. I first distribute. So I distribute the 8. Okay, and then I distribute the -3. Make sure you're doing 8 and -3. So 8 times x is 8x, and 8 times -y is -8y. Then -3 times y is -3y. Now watch what I'm doing. I'm lining up my like terms here, and -3 times x is a positive 3x, and then I have plus 12x. All right, so then I combine like terms. After I've multiplied, I combine like terms. So I've got 8 plus 3 plus 12. That's 11 plus 12, which is 23. So that's 23x. And -8 minus 3 is -11y. Remember, when you're adding and subtracting, the exponents do not change. This is an excellent use of Desmos. So I want to make sure that you guys have that. We have a times b minus c squared. If a is equal to, I'm going to write this down so that I can put that right on. So I want to show you how to use Desmos for these kinds of problems, because this will prevent you from making any mistakes, which is huge, guys. When you're doing these, you really just need to do what you need to do to make sure you don't make any mistakes, especially if you're taking the SOL, also if you're taking the final. So it's a times b minus c squared, right? And a is equal to 1/3, b is equal to 3/4, and c is equal to 3/2. Now, when you're doing substitution in Desmos, you cannot use x or y, so this actually works out well for me because I'm using a, b, and c. So for here, I'm going to say a is equal to, and it's 1/3. So I'm going to do 1/3 divided by 3. Okay, and then I'm going to say b is equal to 3/4. Oops, sorry guys. B is equal to 3/4. Okay, and then C is equal to 3/2. Okay, now what I'm going to do is, now that I've defined these variables and their values, I have to plug it into Desmos, into the equation. So what I'm going to do is copy the equation exactly how I see it, or the expression, I'm sorry. So that's a times b minus c squared. So I'm going to put b minus and c and the squared is inside. Okay, so notice that the answer pops right up. So it's -1/2. So that is my answer right there. So little to no work for you guys, but you really need to practice using Desmos. Okay, same kind of thing here. Let's do the same thing. So we're going to have A is equal to 3, B is equal to -5, and C is equal to 7. And I have 4A minus B quantity squared divided by B plus C. Okay, so back to Desmos I go. So I'm redefining my variables. A is equal to 3. B is equal to -5. And C is equal to 7. And now I enter this in. So I'm going to do a division sign because that creates a fraction for me. And then in there I have 4A minus B in parentheses quantity squared divided by, in parentheses, B plus C. Okay, and as you can see, that's 144.5. So there we go. All right, there's my answer, 144.5. Okay, now when we're dealing with dividing polynomials, remember that you need to divide the coefficients and then subtract the exponents, okay? So the first thing I'm going to do is do 64 divided by 9, right? And then I'm going to get b to the 6 minus -1. We're still subtracting them even though we have a negative right here. And then this is going to be c to the -3 minus 7. So 64 divided by 9 is not reducible, so we're going to leave it there. So I get 64 with a 9 on the bottom, and b to the 6 minus -1 is b to the 7th, and then I get c to the -10. Now here, I cannot have a negative exponent, so what I do is I cross the line and I change the sign. So I get 64 b to the 7th divided by 9c to the 10th. So once I cross the line, this becomes a positive exponent. Okay, now this one's almost directly from the final exam, so be very careful with this. A rectangle has a length of 5x plus 1 and a width of x minus 3. Write an expression for the area and the perimeter. So area is equal to length times width, and perimeter is 2 lengths plus 2 widths. Okay, so let's do the area first. So first thing I'm going to do is multiply 5x plus 1 times x minus 3. Okay, so I do 5x times x, which is 5x squared, and then 5x times -3, which is -15x. And then I distribute the 1 in. So that's 1 times x, so that's plus 1x. And then 1 times -3, which is -3. Okay, so now I have 5x squared minus 14x minus 3, because I have to combine these like terms. So that's the area. Now the perimeter is 2 lengths plus 2 widths. So I'm going to extend this page a little bit. Sorry. Okay, so I'm going to go back to, this is going to be 2 times 5x plus 1 plus 2 times x minus 3. So I multiply first. So this is 2 times 5x, which is 10x. And then that's plus 2. And then that's plus 2x. Now notice what I'm doing here. I'm lining up my like terms. And I have a minus 6. All right? So I get 12x minus 4. And there's your perimeter. Okay, so area is right here and your perimeter is right here. As I haven't said this to you guys, but if you complete this exam review, you can take it with you to the final exam and use it. You cannot obviously use it for the SOL, but if you have to take the final exam, you can take this with you and use it as a reference. Okay, so when we are adding and subtracting, remember that our exponents do not change. When we're subtracting, we're adding the opposite. So what I do is I leave everything the same for the first one, right? So that's 19x squared plus 3x minus 6. And then I add the opposite. So I change every single one of these signs to its opposite. So this is a positive 8x. So that becomes a negative 8x squared. This is a negative 2x, so that becomes a positive 2x. So the negative 7, so it becomes a positive 7. And then I combine like terms. This does not turn to x to the fourth. It is 11x squared plus 5x plus 1. Okay? All right, so let's move on to the next one. So we've done 2 pages so far. Let's see what else we have going on in here. And 4, and then 5. Well, I'm going to go through at least this next page, and then we'll go from there. So now, when we're simplifying this, we're taking the square root of 640. So I'm going to do prime factorization again. So one of the easiest ways to divide this by is by 5, right? So this is going to be 5 times, let's see, 640 divided by 5 is 128. And then I can now divide it by more prime numbers, which is just 2. 2 is easy. 2 times 64, and then 2 times 32, and that's 2 times 16, which is 2 times 8, which is 2 times 4, and that's 2 times 2. Okay, so what I do is I look through this, and if I were to express this as a radical, I'm going to group all my sets of 2 together, because remember, those are what I take out. I have a 5, and then I have these 2s, so I have times 2 times 2. And then I have these 2s, 2 times 2. And if this was a cube root, I'd be taking out sets of 3, right? So this is, now I'm going to take this out, 2 times 2. And then this 2 is all by himself, so he's going to stay in the house, okay? So I take out 3 2s, and those get multiplied by each other. So that's 2 times 2 times 2. They all came out of the house. And then the 5 and the other 2 stay in the house, and they get multiplied together. So that's going to be 8 times the square root of 10. All right, now I'm doing a cube root here, so I'm looking for sets of 3. So the first thing I'm going to do is, again, do my prime factorization. So I know that 432 is divisible by 3. So that's by 144. 3 times 144. And I know that's also divisible by 3. So that's 3 times 48. And that's 3 times 16. And that's 2 times 8. And 2 times 4. And 2 times 2. Okay, now I'm going to put these all under a cube root, and I'm going to group the sets of 3 together. So I have 3 threes right here. So I have 3, 3, 3. And then I have 3 twos. So 2, 2, 2. And then this 2 right here is all by himself. So he stays in the house times 2. And then I have x to the third. So I have 1, 2, 3 x's and y to the fifth. So that's 3 y's plus 2 more. Okay, so this guy comes out of the house. This guy comes out of the house. This guy comes out of the house. And this guy comes out of the house. And then these guys stay underneath. 2 times y, right? So this is going to be 6xy times the square root of 2y squared. All right? Now, let's move on. Now we're doing solving for a variable when we have a literal equation. So if I have a times 1/2 base times height, and I want to solve for h, the first thing I'm going to do is try to get rid of this fraction. So the first thing I'm going to do is multiply everything by 2. Okay, so then I get 2a is equal to b times h. All right, now I'm saying this out loud because I'm saying b times h. How do I undo times? I divide. So I'm going to divide both sides of the equation by b. So I get h is equal to 2a divided by b. And there we go. All right, now let's do another one. We're going to distribute on both sides. So first thing I'm going to do is 4 times 3r, which is 12r. And that's minus 8 is equal to negative 6r minus 21. So now I'm going to add 6r. Oh, sorry, that's not supposed to be an r, sorry. Plus 6r. All right. So I get 18r minus 8 is equal to negative 21. Please don't drop those signs. Be very careful. So I'm going to add 8. And that's negative 13. So I get 18r. 18r is equal to negative 13. And then my last step is to divide by 18. Again, don't be afraid if your answer is a fraction. We are not afraid of fractions. In fact, this world is an imperfect place. Nothing rarely works out evenly. Okay? Now, this guy right here is a perfect example of a Desmos problem. So we want to do x plus 2y is equal to 1 and 2x plus 5y is equal to 3. Now let's go ahead and go to Desmos and just figure that out. Now remember, the solution to a system of equations is where the lines intersect. So I've got 2x plus 5y equals 3. All right. And then the next one is x plus 2y, x plus 2y equals 1. Okay, so I'm going to zoom in a little bit so I can see these points distinctly. Okay, so I want to find out where these lines intersect. And as you can see, they intersect right here. This is a y-intercept and this is an x-intercept. And if I clicked on this line, it would show me the x and y-intercept for this line as well. So this right here is the point of intersection, though. So that is my solution. They intersect at the point where x is equal to negative 1 and y is equal to 1. So those should be pretty much the easiest types of problems that you guys get. So this is negative 1, comma 1. All right, so Alicia has at most, So she has to do less than or equal to of 107 to buy a new baseball glove and a new baseball bat, right? An inequality. So the bat and the glove have to cost less than or equal to $107. Okay. Now this is where the systems of equations can be kind of tricky because you have to come up with some equations yourself. So you purchased 5 more hats than pairs of shoes, and each hat costs $4 and each pair of shoes costs $6. You paid a total of $120. Write a system of equations that represents the number of hats and the number of pairs of shoes purchased. So if x equals the number of hats, we purchased for y, you purchased 5 more hats than pairs of shoes. So we purchased 5 more hats than pairs of shoes. Okay? And then anytime you have a cost problem, remember that's going to be the cost of the hat, or x value, plus the cost of whatever the y value is equal to the total amount of money spent. So those are your system of equations. We don't have to solve it, so here we go. So, okay, once again, one more time, we're going to go ahead and do a system inequality here. So first things first, I'm going to go ahead and subtract 6x from each side. All right, I want to bring the variable to the left side. Now this means that I'm going to have a negative variable, so that should alert me that I'm going to have to change my sign at some point. So this is going to turn from a greater than or equal to a less than or equal to. So I'm going to go ahead and add 6 to both sides. And I get negative 2x is greater than or equal to negative 14. And then I divide by negative 2. And this is when I change it to less than or equal to 7. So remember, less than or equal, when you have the variable on the left, it points in the direction that you need to graph. Okay? So since it's less than or equal to, I have a solid dot at 7, and I'm going to the left. So it's going to be this way, less than or equal to. That's why I like to keep the variable on the left, because this serves as an arrow as to which direction I'm going to be graphing. Okay? All right. So that is the first one that's almost 40 minutes long. I'm going to go ahead and go over the rest next time. But please make sure that if you fill this out that you can take it to the final exam.